In the name of God, who is most merciful and passionate. Students, Assalamu alaikum. My name is Dr. Nayyar Iqbal. Students, you watching Math Home YouTube channel. And students, you know, we are solving questions from your past papers relevant to trigonometric identities. And in previous two lectures, we solved some questions. Students, you know, in first lecture, I derived fundamental identities for you. And I want to repeat again here the fundamental identities. Number 1, sine square theta plus cosine square theta is always equal to 1. Second, 1 plus tangent square theta is equal to secant square theta. And number 3, 1 plus cotangent square theta is equal to cosecant square theta. Students, these three fundamental identities are very important and frequently used in the questions. So students, this is our last lecture of this topic, trigonometric identities, and in this lecture I shall solve some important questions from your past papers. So students, see how we solve these important questions here. This is lecture number 3. Question 8, first part, prove that secant square x plus cosecant square x is equal to secant square x multiplied by cosecant square x. This question is in paper 2, October November 2015. So we solve this question. We consider its left hand side. Therefore, left hand side, that is secant square x plus cosecant square x. So students, you know what is secant square x, that is 1 divided by cosine square x plus 1 divided by sine square x. Now we take LCM of this, that is sine square x multiply by cosine square x. And students, you know cos square x cancel with this factor, and therefore here we have sine square x. Similarly here cosine square x. And students, you know sine square plus cos square is always equal to 1. This is fundamental identity. Therefore we have 1 divided by sine square x and cosine square x. And students, you know 1 over sine square is cosecant square and 1 over cosine square is secant square. Therefore we have secant square x cosecant square x. This is right hand side. Okay, students, now see this question number 6 B part. Prove that cotangent theta plus tangent theta square is equal to this term. This is in your paper 2 exam October November 2012. So solution, consider its left hand side, that is cotangent theta plus tangent theta is square. Students, you know when we open this square we have cotangent square theta plus tangent square theta plus 2 times of their product tangent theta and cotangent theta. So cotangent theta, what is the value of cotangent theta? Students, you know by fundamental identity we know 1 plus cotangent square theta is equal to cosecant square theta. Therefore the value of cotangent square theta is cosecant square theta minus 1. Similarly from here there is plus tangent square theta. This is plus secant square theta minus 1 and plus here is 2 because these two terms cancel out. So students, see here, this is secant square theta plus cosecant square theta minus 2 and plus 2. These two cancel. Therefore we have, ultimately we have the right hand side, secant square theta plus cosecant square theta, that is our right hand side. So students, come to our next question. See here, this is cotangent theta plus tangent theta, cotangent x minus tangent, mean cotangent and tangent are adding and subtracting here. So solution is, we consider its left hand side, that is cotangent plus tangent x and cotangent x minus tangent x. Therefore, you know in algebra a plus b multiplied by a minus b, that is a square minus b square, which means this is cotangent square x minus tangent square x. Now students, see here, again we write the value of cotangent square x, that is cosecant square x minus 1 minus, now tangent square x value from fundamental identity, students, that is secant square x minus 1. Therefore we have 1 divided by sin square x minus 1 minus 1 divided by cosine square x, this is plus 1. And students, this plus 1 is cancelled out with this one, and therefore we have right hand side, that is 1 divided by sin square x minus cosine square x, and this is our right hand side. Okay, now we start our next question. Question 3 here, this is question 3 in paper 1 May June 2013, that is 1 plus cos theta minus sin theta is square minus 2 multiplied by these two terms is equal to 0. So we have its solution, and we take its left hand side, that is 1 plus cos theta minus sin theta, it's square, and minus 2, 1 minus sin theta, and 1 plus cosine theta. Students, you know there is a formula in algebra. I write here, this is a plus b plus c. If we want to take its square, this is a square, b square and c square plus 2ab plus 2bc plus 2ca. We use this formula here at this term. Let's see here, that is, first of all we take square of each of these terms. Therefore 1 plus cosine square theta and plus sin square theta, that is plus 2 cosine theta minus 2, that is sin theta, and minus 2 sin theta into cosine theta, then minus 2. Now we multiply these two terms, these two terms. Therefore we have 1 plus cos of theta and minus sin of theta and minus sin theta cos theta. So we see here, this sin square plus cos square is 1. Therefore we have 1 plus 1 and plus 2 cosine theta minus 2 sin theta minus 2 sin theta into cos theta, that is minus 2 cos theta, and plus 2 sin theta and plus 2 sin theta and cosine theta. So students, we shall see how many terms are cancelled out here. This plus is cancelled out with this negative term. This minus 2 cos theta is cancelled out with this one. This minus 2 sin theta is this one, and that minus 2 is cancelled out with this one. Therefore we get right hand side 0 of this question. So students, let's start our next part of this question. This is question 3, and in your paper 1 October November 2013. So we want to solve this question, that is solution. We take its left hand side, that is tangent square theta minus sine square theta. So students, see here, tangent square theta can be written as sine square theta into cos square theta minus sine square theta. We take this sine square theta as a common factor from these two terms, 1 over cos square theta minus 1. Therefore, we have this one sine square theta into LCM is cosine square theta and 1 minus cosine square theta. And students, you know 1 minus cos square theta is equal to sine square theta. Therefore, this is sine square theta and sine square theta divided by cosine square theta. Because in right hand side we have sine 4 theta, therefore we multiply these two. We have sine 4 theta and 1 over cosine square is secant square theta, and this is our right hand side of this question. So we come to our next question start. This is a question, students, see here, this question is in your two exam papers. One is 403712 October November 2015 and IGCSE 0606 paper 11 November 2015. This is the question. So to solve it, we consider it left hand side, that is secant square theta minus 1, its square root, plus cosecant square theta minus 1, its square root. Students, revise fundamental identities and you see this term is equal to tangent square theta and this is cotangent square theta is square. So we have here tangent theta and plus cotangent theta. Students, tangent theta can be written as, you know, sine theta divided by cos theta and cosine theta divided by sine theta. So when we take its LCM, you see here is sine theta and cos theta. Therefore we have sine square theta plus cosine square theta. And students, on numerator, this sine square theta plus cos square theta is 1. Therefore, we have 1 divided by sine theta into cosine theta. And students, you know 1 divided by sine theta is cosecant and 1 divided by cos theta is secant. Therefore, we have secant theta and cosecant theta, and this is our right hand side. So students, let's start with another question of your exam. So students, see here, this is a question, important question, which is again in your two exams. We want to prove that this square and this square is equal to this one. So students, we solve this question. Again we consider it left hand side, that is 1 plus sine theta divided by cos theta, its square, plus 1 minus sine theta divided by cosine theta, its square. See students, LCM of these two terms is cos square theta. No, this is 1 plus sine theta square. 1 plus sine theta square. You can open this square, 1 plus sine square theta plus 2 sine theta. Similarly here, plus 1 plus sine square theta minus 2 sine theta. Therefore, this term is cancelled out with this term. And this is 2 plus 2 sine square theta and divided by cosine square theta. So students, when we divide separately this cos square theta, these two terms, we have 2 cos square theta plus 2. this is sine square divided by cos square theta. Therefore we have 2 into secant square theta plus 2 into tangent square theta. Since our right hand side, this secant square theta we don't need here, therefore we substitute its value from fundamental identity. You know that is 1 plus tangent square theta plus 2 tangent square theta. Multiply by this 2, we have 2 plus 2 tangent square theta plus 2 tangent square theta. So at the end we have 4 tangent square theta, and this is our right hand side. So students, in this way we solve in this lecture some questions from your past papers. So at the end we have completed a topic of your trigonometry, that is trigonometric identities and fundamental identities. I solved here in 3 lectures we completed this topic, and students, for more questions you can consult any Cambridge book for your home for practice. So students, take care. Inshallah, meet you in next lecture with a new topic of your course of class.